Yes, welcome back. Now, imagine our customer orders a burger, fries, and a drink, and you instruct your chefs to start cooking. So what happens when the customer decides to cancel? Yes, that's exactly where the structured concurrency in coroutines comes in to save you. Now, imagine our coroutine scope as the kitchen, where we have the shelves, we have everything we need to bake a meal. So with a coroutine scope comes everything you need to launch a coroutine. For example, we're going to call our coroutine the kitchen. So we need to specify the dispatcher where it runs. For example, you walk into a kitchen and find there's a cooking gas and there's a cooker. Of course, by default, you would want to use the cooker to save on time. Same thing with coroutines. So with the dispatcher comes the default. You don't specify the dispatcher in which your coroutine will run on. By default, you get the dispatcher.default to run on. So we decided to create a reference to our coroutine scope and specified our dispatcher. Now, in coroutines, we have an hierarchy where we have the parent and the children. It's just like the head chef in the kitchen. The head chef will determine who will cook the burger, at what point will the meals be ready, and when the customer cancels the order, what happens? That's the head chef. In coroutines, the parents will determine how the children will take those tasks. Now, we create a variable reference called order to our coroutine scope. That means our kitchen.launch. Now, with launch, it means we are telling the chef start baking. So once we've already called the kitchen.launch, it means we've already started the coroutine. So we can assign our first chef to work on the burger, second chef to work on the fries, and the third one to work on the drink. The only time this order will be complete is when we have the burger, fries, and the drink. It means all these child coroutines must complete for that coroutine or that order. So remember, all these child coroutines are tied to our order. It means we are only tied to one customer. So if the burger is not ready, it means our entire meal is not ready. It means we don't have a result. It needs to await for the results. And that's where the join comes in. So with the join, it means wait for all the children to complete, and then we can now propagate it to our parent coroutine and say, we are done. That's when we can say now, print to a customer, the meal is ready, and we can serve the customer. So when one child fails, the error is propagated upwards. It means the other children coroutines will fail because the order is not complete. So that means the error is propagated upwards to the parent, and the parent will get cancelled. So we're going to call the kitchen.cancel, which will cancel the entire coroutine. So with the supervisor scope, it means when one child fails, it doesn't affect other children, other child coroutines. So the other child coroutines can continue running and complete their task without the other child. So it means burger is complete, fries is complete, but now we don't have the drink. That is how the supervisor job works. Structured concurrency with Team Zoen, your under chef.